Thanks for coming tonight, ladies and gentlemen. We've got an annual general meeting to get through, and then we've got a special speaker. Peter might give a report on some of the events that have gone on through Science Week. First of all, I'll open the meeting. You've got the time?
Yeah.
I don't have any apologies unless someone wants to apologise for being here, right? Confirmation of minutes. Now, I did have the minutes from last year, but I don't know where they are. Has everybody read the minutes from last year? Yes.
There's a few good guys, so I'll move the minutes.
Can I have someone that will second the motion to accept the minutes? Okay, Simon. All in favour of accepting them? As I recall, they're two simple sentences, the whole minutes. The proceedings tonight will be, I'll just give a quick presentation on the business that went on this year. Then the Treasurer, who is right at the back there hiding, will give his report, and then I'll hand over to Peter, who will dissolve the committee, and we'll go on to the election of the next committee. I'm sure you all agree that this year, in fact the last 2 years, have been flat chat. We've had so many events, and the public have been really supporting the events. And when we look through the Treasurer's report, it shows that we've really had a boomer year. We've blown all the dough, of course, but that doesn't mean anything. We've had a record number of attendances for the public viewing nights, and I think actually if we were to use the ASV membership counting method, which is people that pay their annual fees but don't do anything, we've probably got as many members as the ASV. We've had a record number of school bookings. The astrophotography workshops continue to be successful, and we're still getting people asking could they get onto the next workshop. We've done a number of building renovations. The most obvious is the kitchen, and that's proved its worth on the society dinner. And the barbecue facilities have been beefed up, and we've got some more storage. You may have noticed the container out there, so we're storing stuff in that. The Vastrock was extremely successful, and I think thinking back over the various Vastrocks, it was probably one of the better Vastrocks that have been run. The next one is that going to be Ballarat? The NACE is going to be Ballarat.
Hasn't been called yet.
Yeah, no one put up the hand for it.
Hasn't been. No one wants it.
It'll be interesting to see if there is another Vastrock. The Astro Concert, which was the Music Under the Stars, which we had last weekend. Unfortunately, I couldn't come, but it was a fantastic success from the feedback I've got. I've had lots of phone calls from various people saying what a great thing it was, and people saying you must do it at least twice a year. I'm not sure that the musicians. Sorry?
The band wouldn't want that.
Yeah. But it just shows the types of things that we can get up to, and it got me thinking about over the history of the society. We have always been very pedantic about sticking with viewing nights, and it just shows you how astronomy has changed dramatically. The telescope in the Mini-Me Dome, I'm not sure if it's called the Mini-Me Dome, I call it that, has been upgraded and has a camera. I've yet to see a picture from the camera, but I guess we'll get it at some point in the future. And the committee needs to get its act together, the new committee needs to get its act together on where the society is going, given the plans that the council have for the site. I'd like, before I go on to the committee nominations, which I'm way ahead of you. I'd like to thank all the volunteers. The one thing that we've seen this year, and last year too, I might add, has been the fantastic effort that the volunteers are putting in. We are seeing probably more than I can look back over 50 years of history on the society, and I'd have to say that at present, the effort that's going in from the various volunteers is probably the best it's ever been. We've certainly had individuals who've put in enormous efforts, but we've got quite a crowd of volunteers. I was going to say a herd, but I don't think that's the right metaphor. Before I go into committee nominations, we'll go to the Treasurer's report. Mr. Treasurer, did you want to plug in your computer or?
Yes, please. Just give me a couple of 30 seconds to think while I get this fired up.
Right, while our Treasurer is thinking about what he's doing.
There's no barbecue this Saturday.
Doesn't matter.
There's no barbecue this Saturday. Now, monthly barbecue in council because we did 2 working bees early on in the month and they replaced that barbecue.
Fair enough. You ready?
We'll be back to normal
Sorry,
next
did the
month.
other one. Did the other one go?
Oh, okay. So you're an old technology man, eh?
Actually, my board's broken. We'll push on.
Oops.
They've been changed.
Yeah, well, it's the nature of the beast. When you finish your report, we'll resolve it.
Righto. Okay, quick Treasurer's report. We'll get through this fairly quickly. Main features of the year: income from subscriptions are up on previous year, and some extra events adding to that as well with the Scout and Guide nights. We've had some grant income from grants, as well as some investment in the facilities we have available here with the kitchen, domed observatory and storage shed, and a rise in expenses, but we'll cover that in a second. Quick income from subscriptions, totaling this year $8,000 income from member subs. We have rises in both full member subs, family subscriptions, and also family 5-year subscriptions as well, bringing that up on previous year. Income from events, a lot of event income, as the volunteers and society members will be well aware. We have very popular public viewing nights up to 11,950. Other viewing nights contributing 2,000. School nights up a little bit, 3,800. Astrophotography Day is up a little bit because we took a price rise there last year, so that's gone up a bit. And Vastrock taking is down the bottom as well, so leading to an increase there in takings. Other income, so we have some merchandise sales from the Astronomy Mag, MPAS clothing, some grant income there, and a little bit of interest income, and a slight decline in purchases for resale, so a little bit less spent there. Main expenses for the year, so upgrade to the main building and the kitchen area outside. It's a fantastic job being done out there, it looks really fantastic. And the storage shed as well as the small domed observatory. Rising try-booking fees, the more we sell, the greater those fees get. Advertising fees, we've been using Facebook advertising to drive those PVN sales as well, so they're up a little bit. And grant spending, all of the grant money that's been put through has been spent and a little bit of excess. Some of those assets have been returned here, as you can see by the wonderful pictures and stuff around. So they become assets for the society. Expenses, big list of all the expenses there. Of note, probably the biggest lump is sitting there under the all-weather facility, being the main building here. There's about $12,000 worth of kitchen renovations sitting in there. Working being event provisions, the more events we run, the more those costs rise, as well as our society dinners and bits and pieces. The grants, the spending there on the grants for the Cool Art grant, as well as the Royal Society grants for National Science Week, I think they were. And all the rest of the little bits and pieces. So we have our try-booking fees, postage, website, electricity, and necessaries, rubbish removal, etc., leading to about $33,000 worth of expenses. Should I go forward or backward then? Yeah, no, that's all right. So yeah, there's some once-off expenses there with the kitchen, storage shed, dome, grant spending, leading to an increase in expenses over the year of $14,000. In summary, the numbers all add up to a small profit, $4,109.57 for the year, which is about $6,000 down on last year, largely sunk into the renovation costs in the kitchen. Cash at bank, last slide. Closed last year at about $35,075.41 and closed this year at $40,261.01. Anybody got any questions?
Do you wish to move that this is a fair and accurate representation of the financial status of the society?
I do wish to move that, yes, Peter. Thank
Can we
you.
have someone second it?
Hang on, I've got a question here from the floor.
Just when you first started, Jeremy, on there it said grant 2018 $4,500, 2019 grant $3,500.
Correct. Yep.
Would that be the council shortchanging it or what?
No, it's just what grants were successful in a given year. You put in a multitude of submissions, not all of them come off. So, yes, we were particularly fortuitous in 2018 where we got a decent grant for some bits and pieces here. So, no, it's just the way it works sometimes.
So do we have a second?
Very good. I will stop boring you and we'll move on with the meeting.
By the way, the raffle tin is going around. Always thinking of the money. Okay, well, I'm bowing out as president and handing over to another president who no doubt will be elected. I just want to say thanks for doing that. I've been president for I don't know how long now. And my health and my wife's health, my wife's in hospital at present. We've both been going down steadily. I'm not sure who's going down fastest, but we've decided that we really can't put the time into the society that we'd like to do, and so I've decided that I should step aside. I'm not going out of committee because I've still got things in the Mornington Council that I keep in touch with. And David, your grant for your lighting is. That's right. It's the Rolf Light Pollution Car Park.
I want a plaque under which you want.
Yeah, so I'd like to say thanks to everybody who's supported me. This year I've not been able to put in the time I'd like to have put in, but as I said, the volunteers have done a superb job at keeping the society going, and we're in probably the best position we've ever been in. I was just saying to Pierre, I've got a set of minutes at home of the Frankston Society where the intake for the month was $8.50, well, for the year it was $8.50. So it was in those days when we actually had dollars and cents for income. But now times have changed. All right, on that basis, I will do I dissolve the committee or do
No,
we?
you've got to hand over to me for that, I think.
Yeah, okay, in that case, I'll hand over to the Association Secretary, who will carry on with the general meeting.
Okay, I hereby declare the current committee dissolved, and I better move on, otherwise I'm the only one left in the society. We had nominations for the following positions: myself for President, Mark Stevens for Vice President, Jamie Pole for Treasurer again, Nerida Landcake for Secretary, and the 5 ordinary members: Trevor Hand, who's not here, Simon Ham, Anders Hamilton, Dave Rolfe and Peter Lowe. And there weren't any extras, so we don't need to go for a vote. So I declare all positions filled, and congratulate the committee on the year ahead. It will be a busy year, as it always is. Anyone else interested in committee, we also have the ability to co-opt you in if you're a keen volunteer as well, so that we never turn away a good volunteer. Right, so that is the declaration of the committee. And I'd also recognise that Peter's been president now, I think in total for 15 years, which makes him the longest serving president, behind Peter Norman, who I think was 13 years, so you hold the record there.
Donald Trump.
Okay, so special business, there was no special business declared, so we can skip over that one. And we can now mark the close time as 8:26. End of the AGM. Not the fastest.
It's the second longest general meeting we've ever had.
Okay, well the next order of business is our guest speaker tonight, who's Dr. Ailie Gallant from Monash University, from the School of Earth, Atmosphere and Environment in their Faculty of Science. As some of you would know, our constitution is not just space, astronomy, astronautics, it's also, and I quote, general science. It's one of the changes that was made when we transitioned from Astronomical Society of Frankston to the Mornington Peninsula Astronomical Society. So we're probably unique among all the astronomical societies in Australia for that reason, that we bring in topics other than the traditional astronomy and space ones. So, Dr. Gallant's going to talk about climate change, Mythbusters and communicating uncertainty in an era of soundbites. I'd have to say, when we do public nights and school nights, almost always someone asks something about climate change or makes a comment on it. And of course, when we come to the planet Venus in the slide sets showing the planets, Venus of course has a runaway greenhouse effect, and that usually triggers the discussion when we meet people. Okay, well, with that I'll hand over.
Oh, whatever's easier.
Right, give that a go.
Did you want me to use this thing or?
Up to you. That's okay.
It's better if you can.
Better if I can. Work that out. As long as it. Is it on? Can you hear that?
I hit the mute button, so
Ah, red light, so just press that. There we go. Oh, good. Everybody can hear me. Fantastic. Okay. All right, thank you very much for having me, and thank you very much for the invitation from Ian and Peter. It's great to be here. So, as Peter said, I'm a senior lecturer in the School of Earth, Atmosphere and Environment at Monash University. I'm an atmospheric scientist by trade, so meteorology was my background, and I moved further into climate science, so just longer time and spatial scales, I suppose. Back when I started my PhD a little while ago now. So recently, I should give you the context for how Ian and Peter got in touch with me. We've been trying to do a little bit of climate science education and improving climate literacy in the general populace, and that's a project that we've been running teamed up with some people in Monash University School of Media and Communications, and we've been publishing weekly columns in the local leader newspapers, which some of you might have seen. And we've started that at the beginning of this year, and it's running for 2 years as a trial. But we've had some really positive feedback so far. So I think one of you had seen something in the leader, hadn't you? And got in touch about coming to speak. So I thought I'd go through a couple of things today. First of all, I thought I'd talk about some climate change mythbusters. And by that, I mean, you know, we're often asked as climate scientists about things that people hear from other people or people hear in the media. So I thought I'd clarify some of those, you know, some of those climate change myths that perpetuate. You know, still perpetuate today, but have been ongoing for a long time, because I think that clouds the message. But I also thought I'd talk about effective communication of climate science. I mean, you're probably all well aware that communication of science in general can be quite difficult, distilling quite complex topics. But climate change it's got its own issues as well, which I'll talk about. So, people have often described climate change as, or human-induced climate change, I should say, as a very wicked problem. It's described as a wicked problem because it's wicked to deal with in terms of, mostly in terms of policy, in terms of getting people to think about what needs to be done socially, economically, and all those kinds of things. And scientifically, it's a wicked problem as well because it's highly complex, deals with some very complex interactions within the Earth's climate system. So from the science side of things, I suppose if you look in the left-hand column here, we see human-induced climate change as a wicked problem because of the complexity in the science and what we call interactions and feedbacks between all parts of the Earth's systems that feed into climate change, that we still don't, you know, understand some of these things in a huge amount of detail. And so while that doesn't change the overall outlook, it does change the specifics, and it changes the specifics for different locations. So trying to understand that is still something that's ongoing. Uncertainty in the possible effects of climate change is a big source of making climate change communication very difficult. And by uncertainty, I don't mean uncertainty in that climate change is happening, it certainly is, but things start to get a little murkier in terms of what exactly will happen at the very local scale. And that's ultimately what people want to know about. And so that makes communicating climate change quite difficult, because often there are answers that we can't give on local scales. And when I say local, I'm talking, you know, we want to know what's happening on the Mornington Peninsula in 2090 to, you know, drought or extreme rainfall or something. That's often quite difficult to say. And also the last thing is this prevalence of myths, which is what I'll talk about today. So the prevalence of what we call these climate change myths that perpetuate, particularly around whether it's actually occurring or not. And these have been talked about a lot in the media, particularly over the last 10 years. They're kind of dying down a bit now, but new ones do pop up on occasion, but I'll talk about a few of those today. And in terms of the communication issues, well, communicating science is difficult anyway, but increasingly in this kind of world of black and white messaging in the era of soundbites and 120 characters or less, where we have to get our message across, it can be increasingly difficult to get those simple messages across. And I'll talk about some of the other issues that we have with communication. And in line with looking at these myths and the perpetuation of these myths in the media is this quest for balance. And this quest for balance in the media where there isn't balance in the science. And the consensus is somewhere where the media suggests it's not, which has improved over the last little while. So I'll talk about a couple of those things today. So let's first start with some climate change myths, and I'm sure everybody has heard or has questions about these, so I'm happy to take questions at the end on things that you might have heard of that hopefully I can shed some light on. But the myths generally fall into 4 main categories. So the first is it's not happening. Climate change, human-induced climate change is not happening at all. The second is it's happening but it's not as bad as we're led to believe. The third is it's happening but it's not us. And the fourth is that more carbon dioxide and other greenhouse gases are actually a good thing. So they generally fall into one of those 4 categories. So let's start with it's not happening. And these are some of the common ones, and I'll only talk about a couple because it will take too long to talk about all of them. So some of the common myths is the climate has changed before, so it's not us. Temperature records are unreliable. There is no consensus between scientists, and undermining the consensus. The fact that climate models, some people say climate models are unreliable, and I can talk about that one at the end actually, because I don't think I talk about it in too much detail. Temperatures are cooling. This was more prevalent about 5 or so years ago, but seems to have disappeared as we've gone through an era of accelerated warming in the last 5 years. And lastly, that changes in carbon dioxide lag changes in temperature, therefore it can't be a causal mechanism. So I do talk about the models. So I'll talk about these 3 today. So the first one is the climate has changed before, so it's not us. And first of all, if you think about it logically, just because the climate's changed before doesn't mean it's not us now. There's several different mechanisms by which the climate can change. Many mechanisms by which the climate can change, and we understand a lot of them quite well. So saying it's not us this time kind of is a bit of a logical fallacy really, because the climate could have changed before for many other reasons. But this time we're very confident that it is us. So this picture here basically illustrates why, or one of the lines of evidence why we can say it is humans causing human-induced climate change and not any other reason. So what this is a field of climate science that we call detection and attribution. So what we do is we have a look at the observations, and those are indicated by the black line here, and you'll see I have 3 plots here. So this is temperature change across global land surface in black, temperature change across global land surface and ocean surface in black in the middle plot, and on the far right, what we call ocean heat content, so a measure of basically how much energy is being stored, heat energy is being stored in the oceans. And then we use our climate models, and I'll talk more about climate models in a minute. We use our climate models. We use those models assuming what we call a counterfactual world. So a counterfactual world is basically a world in which humans never went through an industrial revolution and emit huge amounts of greenhouse gases. So we keep our carbon dioxide equivalent levels at around 1850 to 1880 levels, and we let our models run. And we let them run for hundreds of years. Model time, not actual time, that would be ridiculous. But in model time, and we have many models. These things run on the biggest supercomputers in the world and take a long time to run. They're very complex. But basically in this counterfactual world where we have what we call natural forcings only, in other words, we don't have that additional input of the greenhouse gases, that's what you see with this blue shaded area in all these plots. Okay? So it's a shaded area because it's not just from one model simulation, it's from about 30 different models, and each of them have several different simulations. As I said, they take usually depending on the supercomputer, anywhere from 2 to 6 months to run one simulation. So you can understand that we can't have thousands and thousands of these simulations, although increasingly, thanks to citizen science projects, kind of like the SETI project actually, there's one called climateprediction.net where you can run a climate model at home on your own computer when it's in downtime. we can have a lot more simulations. But these particular ones are from I think it's about 100 simulations. Now the pink here basically shows the real world. So it shows a world where we started to emit greenhouse gases in the late 1800s, and it shows the world where we did emit these greenhouse gases at the rate that we observed. And what you see here is that the black line doesn't follow the blue shading. It follows the pink shading. And so basically, and you see that in all cases. So basically what this says is, on the global scale, it is impossible for us to simulate the observed changes in global temperature from the land surface, from the land and ocean surface, and ocean heat content without having greenhouse gases, additional greenhouse gases in our models. So in that sense, it's really quite clear from the science that it is us. And in fact, the Intergovernmental Panel on Climate Change, in their last report released in 2013-14, basically said that it was virtually certain that humans were influencing the climate, which is a really strong statement for a UN body. So the second myth is that there is no consensus. I'm not going to harp on about this one because it's just blatantly not true. There was a discussion going around a few years ago about some petition where they apparently got 30,000 scientists to say that global warming didn't exist, but if you actually looked at the list of scientists, very, very few of them were climate scientists. In fact, I don't think any were. Some were meteorologists, but most of them did not have a background in atmospheric physics or anything like that, which is interesting. But in terms of the consensus, there was another study that came out by a gentleman called John Cook, and this infographic is from this project, where he looked at tens of thousands of peer-reviewed scientific papers. I think it was from the early 2000s or the late 1990s. And they looked for keywords about whether or not the paper agreed with the concept of human-induced climate change or it did not. And they found, a conservative estimate, I should say, was that 97% of climate scientists agreed that human-induced climate change was caused by humans. Global warming was caused by humans. And it's also an example where we have this IPCC report. This is just an example from the last report, had over 300 convening lead authors, 436 additional contributing authors, 48,000 reviewer comments from over 1,700 expert and government reviewers. So basically the process is that the IPCC, they get together and have their meetings. In fact, they're having one next week in France. They write what the experts who are experts in their field, and they're all assigned to different chapters for which they're experts. They write the chapters, and then it's sent out for review, and pretty much anybody who wants to can review it. Anybody. Even anybody in this room if they really want to. You have to state your expertise in your background and things like that, but you can all review it. And every one of those review comments has to be looked at and has to be acknowledged and has to be answered. So it's a very, very arduous process, but it ensures that the consensus view is represented. And I just like this infographic. It came out a few months ago. This was from NASA. I just thought this was a fantastic piece of communication that showed this is what disagreement looks like in terms of climate change and global temperature increase. And this just shows global temperature change as measured from a number of different data sources, which I'll explain in a minute because I'll talk about that. So another one that comes up quite a lot is that climate models are unreliable. Now I wanted to ask actually everybody here about how they think climate models work. How do you think a climate model actually simulates the climate? Yeah?
Where the temperature is increases and the worst greenhouse gases are released in the atmosphere.
Yeah, and that's certainly the theory behind what goes in the model. But in terms of how the model does that, do you think it uses past trends to understand future trends, or do you think it works? How do you think it works? Yeah. Yeah, exactly. Yeah, so what you're saying is exactly right, and I'll get to that in a second. Yeah.
Doesn't it use existing data to predict on stuff?
So that's the common perception, but no, it doesn't. So what you said at the back there is exactly right, in the sense that what we are representing in these models is physics, okay? So these are physical models. We put in physical equations about thermodynamics and about dynamics, Newton's laws, for example, okay? First law of thermodynamics, second law of thermodynamics, all of that stuff to do with physics, microphysics, chemistry goes into these models. There is no existing data put into these models. These models do not extrapolate trends, okay? The way that they work is that they use physics to simulate. We start them off, they actually start with a very cold Earth, and we let them do their thing and bounce around for a good 500 years of model time until they equilibrate. And they equilibrate based on parameters that we give them, which are based on observations, but they're not actually extrapolating trends. And so what I wanted to show you here was how well climate models actually do, given that they've got zero observational data put into them. The top one here shows a simulation. In fact, I'm not even sure which one's obs and which one's model, now that I think about it. No, this one's obs. So the top one shows observations of annual rainfall, average annual rainfall around the globe. And you can see the colour table down here. So basically the blue and white areas are wetter areas, and the red and the yellow areas are dry areas, or yellow somewhere in between actually. So this is what annual rainfall looks like around the world. So we get most of it along the equator here. We get a little bit dipping down into the South Pacific. This is called the South Pacific Convergence Zone. Most of it's in the tropics. We get some extension into what we call the mid-latitudes. And you can see that the model does a pretty good job of getting that general pattern, given that it's had no observational data put into it, okay? And in that sense, there are some things that aren't quite right, for sure. For example, this thing here is a bit too far north. This doesn't extend down as far as it could in terms, over some of the continents, some things aren't quite right. Spots and bullseyes kind of in a little bit of the wrong spot. But on the whole, it does an excellent job. But models are never perfect. No model for any scientific process is going to be perfect. They can't be, they're just models, okay? So there's an old saying by a guy called George Box, who was a mathematician, who said that models are all wrong, but that they can still be useful, okay? And that's very true in the case of climate science. They're never going to be perfect, they're never going to simulate the observations perfectly, but they can still be very useful in telling us. They still do a good enough job of simulating the observations, but they can tell us some very useful things. So in that sense, it doesn't mean that the models are unreliable, because it does depend on their purpose. And for these models on large scale, so global, hemispheric, even continental scale changes, some subcontinental scale changes, these models actually do a remarkably good job. And for things like temperature, the models do a remarkably good job. When we start to get down to things like simulating rainfall over Beijing, that's where the models don't do as well. So we need to be clear about our expectations for the models. But to say they're just flat unreliable is simply false. All right, so the second kind of main category of myths is it's happening, but it's not as bad as we've been led to believe. So here are some of the common myths that I've certainly heard a lot. The climate is not as sensitive to carbon dioxide as it's reported, and the expected warming is actually much smaller than it's reported. The second one is that the amount of carbon dioxide in the atmosphere is so tiny that it can't possibly affect climate, and I'm sure all of you in here are familiar with why that's not true. The third one is that we're heading into an ice age. That was a very popular myth in the 1970s, which kind of got perpetuated, but it seems to have disappeared now. And the last one is that most of the warming is because of cities and towns, this urban heat island effect. So I'm going to talk about these two. First of all, that the climate is not as sensitive to carbon dioxide as reported, and the expected warming is small. And the second one is about the influence of cities and towns, because in this project that we've got where we put these reports in the leader newspapers, this is often one of the questions that we get asked. So, the climate is not as sensitive to CO2 or other greenhouse gases as is reported, and the expected warming is small. Well, this is basically the range of what we call climate sensitivity. So what climate sensitivity means is, if we were to double carbon dioxide in the atmosphere above pre-industrial levels, how much would the globe warm? So with the doubling of CO2, how much would the globe warm? Now, you can make a lot of decisions that go into your model. You can test the sensitivity of that, but basically, every single Intergovernmental Panel on Climate Change report since the first assessment report, which was back in the early 1990s, I think, or late 1980s, has shown not much change in this climate sensitivity. So our expectation is that it's anywhere between about 1.5 degrees and about 4.5 degrees. It's increased a little bit in the last report, both up and down, but more up than down. And that's largely, well, it's for a number of reasons, and it will probably change slightly again with the next assessment report. So why do people say it's not as sensitive to carbon dioxide and reported and the expected warming is small? Well, this comes to the decisions about these things called feedbacks in the Earth's climate system that make a big difference. And the people making the claims that the expected warming is quite small have made what the vast majority of climate scientists would say are poor decisions about feedbacks. So feedbacks you can consider as an example of a positive feedback is a snowball effect, right? So you start with something and it's amplified. An example of a negative feedback is if you start with something and it's dampened. So we have heaps of these in the climate system. One you might have heard of is the ice albedo feedback. So if you have, for example, the warming in the Arctic, you have less sea ice. That means that you have less of the incoming solar radiation being reflected from the surface, more is absorbed in the surface, it warms, it melts more ice, which then changes that balance of that incoming radiation again and again and again and again, and you basically get amplified warming in the Arctic regions because of that. Particularly the Arctic rather than the Antarctic, because it's a lot harder to melt the, the Antarctic ice cap won't be melted for a while, but sea ice does play a role too, a big role. So in that sense, decisions about that feedbacks like that. There's also other feedbacks with clouds, and this is the particular one that changes the climate sensitivity. And scientists have been looking at this, climate scientists have been looking at this, and atmospheric physicists for many, many years, trying to pin down exactly how these feedbacks work in the cloud. And we think we've got a pretty good idea now. And you can see that it hasn't really changed much. So in the sense that, do we get more high clouds? Do we get more low clouds? That makes a decision that makes an important, that's important for how the Earth either retains its heat or reflects heat from the sun. Yeah?
I heard something that they're using cloud seeding as a way to cover certain areas so it helps climate change so it reflects the sun. Have you heard anything about that?
I haven't heard about that in that context. I've only heard it in the context of seeding for rainfall.
Yeah, I've heard that, that it helps climate change, prevent it.
I've heard about it, not so much cloud seeding, but yeah, putting silver iodide particles and stuff, further up to reflect more sunlight. I have heard about that, but yeah, that gets into all sorts of very complicated political machinations, because the question is, does one country have the right to put stuff in the atmosphere that's going to circle the globe and all that kind of stuff? There's actually some really interesting papers too that have shown that by doing that, although you cool the globe, you actually change rainfall patterns in a way that's unexpected.
Yeah.
So it's very interesting. But geoengineering is that area which is really, really interesting. So in that sense, I think we're pretty confident that the climate sensitivity that we have is about right, given what we know. And the final one is that most of the warming is in cities and towns. And this is a particular one that's been doing the rounds here over the last few years. One of the people who wanted to talk about this a lot and actually caused an inquiry into the Bureau of Meteorology was Senator Malcolm Roberts. I don't know if you remember him. But ultimately, it's just not true. So this basically shows every single line here, shows data from a different source. So the grey line is from a series put together by the Met Office in the UK, where they've taken global stations as best as they can and reconstructed temperature since around 1850. NOAA is a US version. NASA is, this is satellite data. Berkeley Earth, this was a fantastic situation. So this was a physicist who was at Berkeley who said, I don't believe that these temperature records are showing what I think they're showing. I'm going to put together my own team and show that they're not. And then he put together his own team and went, oh, actually, they are. So, and he changed his mind completely about human-induced climate change because he did the work himself. So good on him for doing that. So that's the Berkeley Earth, which is the dark blue. Carlton and Waves, just another group that did it. Era Interim is just another, I'm not going to go into what that is, and the JRA 55. But the point is that they're combinations. These show combinations of satellite data. They show, and when I say satellite data, that's at the lower atmosphere. It's not necessarily at the surface, so it's the lower part of the atmosphere. Temperature observations from thermometers around the world, things like that. And they all fundamentally show the same thing. You get a little bit of divergence at the start, and some of them don't come in till later because of, satellite data and all that stuff. But yeah, they're all very similar. Okay, so the third myth kind of category group is that it's happening but it's not us. So some of the common myths, it's the sun, it's part of a natural cycle and more CO2 is a good thing. I'll just get rid of it, it's part of a natural cycle, because if it was a natural cycle we would actually be heading into an ice age, and there's absolutely no indication we are. So it's the sun, more CO2 is a good thing. So this is a plot, sorry, some of the lighter lines haven't come up that well, but the darker lines show 11-year average temperature and 11-year average solar irradiance. And you can see the sunspot cycle in there, which I'm sure you're all familiar with, that 11-year sunspot cycle. The lighter colours show that. They show up on my screen, but not on this one so well. You can see that there. But basically you see this divergence, complete divergence, particularly after kind of the 1980s between those cycles. And there's no reason why it would be the sun, in the sense that the changes in the sunspot cycle too are far too small for the changes that we see there too. So more carbon dioxide is a good thing. This is another one that's done the rounds recently. And to a point, actually, they're right. To a point. So there are benefits for agricultural productivity for carbon dioxide, more carbon dioxide, and there has been what we call a global greening. So basically you can see the change in what we call leaf area. Okay, so if you look at satellites and you measure how much of the globe is covered in what we call leaf area, so they literally take tiny pixels and measure that, it's increased, and it has increased. So that means the vegetation at the moment anyway is basically thriving on the additional CO2, because it effectively, in very crude terms, eats CO2. This is called the CO2 fertilization effect. And this has become, so in that sense we are greener, and warmer temperatures do help for longer growing seasons in some areas. But the point is that is only a very short-term thing, and as we move forward into an era of more global warming, basically when we think about rainfall changes and temperature changes and extreme temperatures and stress on plants from those things, unfortunately we get to a point where the benefits of CO2 fertilization, the benefits, are outweighed by the negatives of the changes in other aspects of the climate. And that happens not too far down the road. And it also depends where you are too. So for example, somewhere in Russia where you've got really, really cold winters, warmer temperatures and longer growing seasons are possibly a good thing. Down here for us, it's not so good at all, because extreme temperatures can have big effects on wheat varieties. And we had someone come in and talk to us about milk production from cows, and apparently it sinks through the floor at above 25 degrees Celsius. So in that sense, not so great. So in that sense, moving towards the end of the 21st century, the best evidence is pointing towards the negative effects outweighing the positive. So I've gone over some of the myths here, but I thought instead of debunking just the myths, we'd really talk about, well, how do we know that human-induced climate change is actually happening? So let's talk about that in kind of 5 pillars. The first is the theory, okay? A theory and the understanding those physical underpinnings of how climate change works. The greenhouse effect and understanding how water vapour and rainfall might change with changing temperatures across the globe, for example. So we understand that theory really, really well. We have a really good handle on the physics behind how the climate works, how the weather works as well. I mean, this is what allows us to get, some of you might disagree, but actually very accurate forecasts up to 5 to 7 days in advance. And basically you can think of climate models, speaking of climate models from before, as cousins of weather models. They're ultimately based on the same physics. The second is that the strong trend in carbon dioxide and other greenhouse gases. So we have very strong trends in those. We now know that carbon dioxide is at a level that's not been seen for a very long time. At least, we've hit 400 parts per million, which has not been seen since some era that I can't remember the name of, millions of years ago. Observed climate change. We have a lot of what we call fingerprints of climate change. If you kind of think about it like a forensic crime examination scene, we have DNA fingerprints. Well, we also have observed climate change fingerprints. There are ways that we would expect the climate to change if it was humans. There are ways we would expect the climate to change if it wasn't humans and it was some other natural process. And the way that things are changing is all in line with the human-induced cause. And of course, the significance of, when we talk about significance, like the statistical significance of those trends as well, okay? The fact that they're huge compared to what we've seen, even in the last million years or so, some of them. And also the missing alternative. There's no missing alternative explanation that fits with any physical theory that we know. So that's how we know it's happening. So now, how do we communicate to people effectively? And so this is a project that's run in conjunction with, so we call it the Monash Climate Change Communications Research Hub. And it's about improving climate literacy through these local newspapers. So some of the key principles of effective communication that people have talked about for a long time and getting scientists to communicate is, being a trusted and confident source, using concrete real-world ideas, leading with what you know, selecting effective visual communications, all that stuff we kind of know. But the really hard thing, I think, particularly with climate change, is about connecting with what matters to the audience and telling human stories. And there's a reason that's so difficult. And basically it's the obstacle of personal disconnect. So when we think about climate change, as I described before, as a wicked problem, it is a really wicked problem because people have real trouble understanding it in a personal context. So it's very distant in space and time. You often hear people or predictions, or what we call projections, I should say, not predictions, in the media talking about, the change in global temperature in 2100. What does that actually mean for you on the ground if we say there's going to be a 4 degree or 5 degree or 6 degree change in global average temperature in the year 2100? how does that translate to back where you live? And that's why it's not relatable. And that's why it's really, really, really difficult to personalise. And there's also, as I said, a lot of uncertainty, I shouldn't have said in the science there, but in the projections, okay? Largely because most of this uncertainty, so yeah, it's not uncertainty in the science, it's uncertainty in projections, although there is uncertainty in the science, but that's small compared to the projections. So the way the projections work is that basically if we want to make predictions about climate change for the future, we have to make all sorts of assumptions about greenhouse gas emissions into the future. And so that's where the economists come in, and the people who are experts in policy come in, and international relations and all those kinds of things. And they make up a number of scenarios for us, and they say, okay, well, if we assume this is going to happen and this is going to happen and this is going to happen, the world's going to emit at this rate. And we say, thank you very much, we put it into our climate models, this is what happens to the climate. Oh, well, let's make up another scenario. What happens if this happens? So, you know, usually there's differences between what we call a business as usual scenario, where we keep emitting kind of at the current rate, and then there's a rapid transition, a very rapid transition assumption that says, well, you know, within the next 10 years, we basically decarbonise the entire planet, move to renewable energies and things like that. So those are kind of the two extremes, and there's a whole bunch of stuff in between. And so because we don't know exactly what's going to happen, understanding and predicting the future of what's going to happen is super difficult, because most of the uncertainty in the future projections comes from the differences in those assumptions. So down the bottom, this is change in average precipitation across the globe. On the left here is a change in average precipitation. You can see greeny blue colours are increases in precipitation, and yellows and oranges are decreases in precipitation. But the scenario on the left here shows a change where we rapidly decarbonise and we reduce our emissions hugely and basically get back to kind of, you know, pre-1990 or early 20th century emissions within the next 10 years. Whereas the one on the right is that business as usual scenario. And you can see the huge difference of the changes in precipitation associated with those two scenarios. So let's just take over the Arctic, for example, or over parts of China, over parts of India. You can see there's almost no change detectable at all under that low emission scenario, but there's a significant increase of kind of 20-30% in precipitation with the other scenario. So in that sense, it's really hard to provide personal information. There is also uncertainty at that local scale, as I was discussing very early on as well. So we've had a go at overcoming the personal disconnect in some ways, not so much to do with projections, but to try and get people talking about climate science and understanding some of the nuances of climate science. So we approached the leader newspapers a couple of years ago, and we got a grant and their agreement to start publishing these. These have been done in Melbourne first. It looks like we're going to start doing this in Brisbane and Perth as well. And also some of the news media has picked up on it in terms of the television news media as well. So we now have Paul Higgins on the ABC, who gives these graphs and discusses them about once a month, usually at the end of the season. Jane Bunn on Channel 7 does the same thing, and we've got a couple of people interested in looking at them up in Sydney and Brisbane as well. But what this column aims to do is to provide local climate information with really relatable climate metrics. Simple graphs and information. It's what we call non-advocacy communication. This is not designed to say, look, things are changing, you have to do something about this, go and lobby your local politicians. That's not what this is designed to do. This is simply designed to improve climate literacy. So it's just the facts. Here you go. Do with it what you will. This is the interpretation. This is the physical theory behind that, and we do give information not only on climate change, but on things like what we call the urban heat island effect. So the fact that all of these stations, some component of the warming that we see in all of these stations will be because of build-up in urban areas. More concrete stores more heat. So not all of that warming comes from climate warming. A lot of it does, but not all of it. So the point is we talk about those things as well, and we talk about some of the nuances. So things aren't so black and white. And we also provide local perspectives as well, which I'll talk about a bit later. So these columns are in the leader newspapers every week. So we basically use these stations around Melbourne, and we apply, we basically use the closest station to wherever the leader is. So we make sure our language says it's not at your location, it's near your location. But these stations are all ones that have at least 20 years of data, often a lot more. The Melbourne City Station at Olympic Park, for example, has temperature data back to the 1850s. Some of them, Scoresby, Moorabbin Airport, Laverton, they all go back a long way, so we're able to talk about long-term climate changes. These are all from the Bureau of Meteorology. We implement our own quality control to make sure we're happy with the stations and we're happy with what they're telling us. And then we have really simple metrics. So we talk about average monthly temperature, minimum temperature, maximum temperature, the hottest or coldest day or night in a month, number of days where, for winter we've done some recently where number of days with temperatures below 15 degrees Celsius. In summer we might do number of days over 35 in a month, things like that. But we've found they've been really popular and very, very well received because people also just like to know what's going on with their local climate. And that's the other opportunity in these columns is we can just talk about fun things that have happened. If it happens to be a really hot month, a hot January, we can say, oh, well, look, there was another hot January back in 1975, but you can see the trends going upwards, for example. And I just pulled out one for Cranbourne because I figured it was the closest to here. We do have Frankston as well, but unfortunately they've just closed the Frankston station. So we can't. So we're not going to be able to use that going forward, which is a real pity.
Is that because it was on the end of the year?
Well, yeah, actually that was coincidental. They closed it before that happened. So, yeah. Yeah, I think they must have. I don't know. After, what was that, 2 weeks ago or something? Yeah. But yeah, they actually made that decision before that happened. I think decision would have been made for them. So so we provide this really simple data here. This is a really great example of one here because we make sure that if we're not happy with the data, we remove it. We talk about this variability. It gives us an opportunity to talk about, why temperatures go up and down from year to year, but it also gives an opportunity to talk about the trends and what's causing the trends. And as I said, the ultimate aim is to improve climate science literacy in the general population. And establishing that personal connection. So every column typically has a local story as well. So people write into us and say, oh yeah, I've noticed this or I've noticed that, or I remember this time back in 1992 at my cousin's wedding when we had this massive storm and blah blah blah, something like that. We absolutely welcome your perspective. So if you do want to contribute and tell us your story about how you feel the climate's changed around here or near you, you can email us at leader@monash.edu. And that will get through to our team who will store your comments. So because of the realities of climate science, effective communication is difficult, but we feel like we're moving towards this. Now this is not soundbite kind of media. This is old school media, because we kind of felt that soundbite media can miss a lot of important complex information that's currently missing from the conversation, and so we felt like this was a great opportunity to really educate people about climate science. That's about all I have. So if you want information on the local newspaper project, you can go to that website, or digestible and reliable resource for scientific facts on climate change and some of these answers of climate change myths. That's a great website by this guy, John Cook, called Skeptical Science. But thank you, and I'm happy to take any questions. Not sure if you wanted the light back on or... I think the hand was up first.
In 2010, I took a 32-hour trip to the North Pole, right?
Mm-hmm. That's a long
This
time.
council It's just said that we've got to do something emergency about climate change. I told them 6 years ago, in 2014, the temperature in Greenland had risen by 2 degrees. I went down the fjord and I seen the icebergs that had melted 30 metres.
Yeah.
David Attenborough's been on about it for 40 years. Prince Charles has been on about it. I wrote to Prince Charles, I wrote to everybody except Santa Claus. And still, we're still a sloppy load of people, because a lot of people say, oh, that's not going to happen. For the first time in history, 30 billion tonnes of ice has just melted in Queensland, and still this council saying, I think we ought to be doing something. Are we dealing with imbeciles or what?
Yeah, action on climate change is another very big issue and complicated. Yeah.
I think one of the things in the communication side, that we get to talk about climate a lot. We do our monthly talks. I talk about climate on other planets, what's been changing there. And the thing that comes across, from my point of view, is that, particularly with the younger generation, is the number of times they don't want to know the facts. What they do is that they're looking for someone to blame. And I had the two, I guess they were high school, or maybe they might have been early university students, and they were just blaming the current generation for doing it. And their view of climate change was that it's happened last week. They have no view of it. And all the science, which is quite valid, and the variability, they don't understand that. You put a graph in front of people, and most people don't understand the graphs.
No, that's right. And I think this is one of the big issues as well, is actually getting to this from the other perspective as well, because one of the issues that we find as climate scientists is the opposite now as well. Not climate change myths. And I don't want to call it climate change hysteria, because it's a really important problem, but what we find is everything is climate change.
Yeah.
Something happens and everything is climate
That was
change.
going to be my
And that's not the case at all. And I'm not saying that climate change hasn't influenced things. It's hard to tell. But in some cases, let's take the recent drought in New South Wales. I'm doing a study on that with some colleagues at the moment, just having a look at how bad it is compared to past droughts. We've found 4 similar droughts. Granted, we haven't used this year, this is 3 years in a row, but for the past 2 years. And I'm not saying there hasn't been some other influence, but we can't find it. Not yet.
One of the things that I've found is that the media are totally science imbeciles. They do not understand the science at all. And so they tend to sort of say, it rained today, it's climate change. It's cold today, it's climate change. And so they throw out this explanation in 2 words, climate change.
Yeah, and this is the big problem, is this real black and white
So a
messaging.
big part of,
yeah.
for your program, I think, a big part of that is educating the media.
Oh, absolutely, and that's exactly what part of this is. So we ran a workshop before it went out with those people who agreed to do it, and we talked to weather forecasters, not weather forecasters, what do you call them? TV meteorologists, who the vast majority of the time have no science background whatsoever. There are a few exceptions. Yeah, there are a few exceptions, but they gave us perspectives on what they know and they can communicate, and they feel they can communicate to the general public, and it was quite interesting. But anyway, I'll move on. I think there was a question up here and a question over there. Yep.
When you're communicating with the public,
Yep.
those last graphs you showed, especially the one from Cranbourne,
Yeah.
it's local to our area.
Yeah.
Do you deliberately not show too many graphs, or because there's a few overlays, maybe like a bell curve or a parts per million in carbon?
Yeah.
What do you choose to take out so that it doesn't overwhelm people? Like, how do you come about putting stuff in and taking stuff out to
Yeah,
get the message across?
that's a really good question, and we had long discussions about this. Do we even put in a linear trend line? Do we make it linear? Do we make it, what do we make it? Do we make it polynomial or something like that? We had a lot of these conversations. In the end, we felt linear was the most digestible. We haven't put any measure of what we call statistical significance on it, we use it behind the scenes, but the general public typically don't understand what it means. So we wanted to keep it as simple as possible. What we do, because we've got a column every week, we're actually typically been doing climate indices until, like metrics until now. But the last couple of weeks we actually engaged the services of a company that measures emissions on the very local scale, down to electricity, transport use, waste, and all that kind of stuff. So we've been putting those graphics, pie charts, and things like that into the columns, and they've been very well received as well. Just showing people, breaking down, well, where do most of our CO2 emissions come from in this area? So that's been, but yeah, it's tricky because, like someone said down here, even graphs are hard to grapple with. So yeah, it's not easy. Yeah.
I just had a question. I don't know if you remember back in 2008, they had a ad or where the balloons was leaving the appliances for trying to reduce greenhouse gas emissions, just for local households, and then they started pushing, the free LED light bulbs and all that. I was going to say, has there been any statistical data that's actually helping reduce our emissions?
I don't know, to be honest.
And because there was a lot of push for like the Powerball to the timers and stuff like that from the government as a way to help reduce our...
Yeah. So I think, if I remember correctly, we've actually discussed this, I think, in columns in the last couple of weeks, and I think personal energy use has reduced in some places. But energy use from other stuff has not, and particularly industry and things like that, and waste and stuff like that. But population growth swamps that. So per capita, it might have reduced, but as soon as you get, the suburbs where there's huge population growth, and I'm talking kind of the northern suburbs and the western suburbs, up it goes. So yeah, but I don't quote me on that, because I don't know that stuff particularly well. Now there was a question over there who's had his hand up for a while. Yes.
Do you have any suggestions of how to communicate a positive message to younger children? Because I deal with a number of young kids in Scouts, and many of them are aware of climate change and they believe it's true and they're worried about it. What can we message to them that is less than doom and gloom?
Yeah, and that's a really good question. It's something I struggle with every day, because I teach undergraduate students in a Bachelor of Science, and when I teach them climate science, they come out of my subjects quite depressed, and it's not fun. Look, I suppose what I tend to put positive messaging around is that there are differences being made. A few years ago there was a fantastic statistic about 1 million solar panels on roofs, and it's just going gangbusters. And even the things like the LED lights, and talking about the fact that personal energy consumption has reduced a lot, and can be reduced, and it's actually quite easy to do, and it's quite easy to change personal habits, but it's hard, because I think ultimately, whether it's a bottom-up approach or a top-down approach, by that I mean, things being done at a grassroots level as opposed to a governmental level, what's going to make the actual difference? I'm not sure. But I suppose the only thing that I find helpful is to empower them to say that they can do something about it. But yeah, to be honest, it's a tough one. It is a tough one. I'm not sure that satisfactorily answered your question, because I struggle with the same thing. I really do. But I think in terms of just being positive about what individuals can do, because that does make a difference, but it's a small difference. But yeah.
Doom and gloom then.
Well, no, yeah, not quite, but yeah, yeah.
I'm an ex-physics teacher and a science follower for many, many years, about 65 years of it.
Yeah.
As I see it, the politicians and people who seem to push these things want black and white answers. Science does not work in black and white answers. It works in probabilities. Now, my comment is that if you had a 95% chance that when you cross the road you'd be hit by a bus, would you cross the road? And I see the same thing with climate change. It may be untrue, it may not even happen, but there's only a 5% chance of that. The other 95% chance is that it would probably happen. I mean, even Einstein's ideas and and Newton aren't 100% sure. They're
It's
maybe
theory.
90.
It's all theory.
It's called theory making. And that's what we used to teach our Year 10 students. This used to be one of my students. And pointing out that theories are not certainties.
There is no certainty. Yeah, absolutely.
I'll also make a comment about, if I may, about one of the comments you made. You made it on 2 occasions, and that was that you said we didn't use some of the information, or we didn't. I can't remember the wording.
In what context, though? In what context?
Oh, when you were communicating via the newspapers and so on, and got information in, you
from the general public.
You modified the information.
You filtered out the
charts. That's easier.
Sorry,
No,
I'm a bit lost.
Charts. It was just information generally. No, look, I'm sorry. I've forgotten the exact details. Other things have happened since then. However, I think this is going to be the biggest problem in getting the idea across to people. There was an interesting cartoon on YouTube, not YouTube, Facebook. My wife used to have Facebook, and I occasionally look at her Facebook. But there was a comment about the fact that I'm having difficulty remembering the exact wording, but it was to the effect that what would happen if all this climate change was untrue, and we made a better world for nothing?
Yes, I've seen the same thing. Yeah, there was a question here, I think.
I noticed that we're talking a lot about climate change, but the fundamental thing is really global warming, isn't it?
Well, no, it's climate change too. I mean, it's one and the same thing in the sense that it's clear signal is warming of global temperatures, but we are talking fundamentally about changes in the climate at the local level.
The thing that I think is possibly, I don't know, one reason why people aren't reacting strongly is climate change doesn't actually have a positive or a negative connotation. It just says it's changing. It's changing for the better, it's changing for the worse, or whatever. It doesn't state that. Whereas if you actually talk more about global warming, and you certainly do it if you talk about it in the middle of summer, then people will start to appreciate what the danger is here, that we're actually, we're going to see a warmer world, and their minds can possibly relate better to the results of that.
Yeah, I mean, I think one of the fundamental issues with that is that on that local level, one, some of the signals aren't very clear, and two, there could be benefits and, there might be some benefits, but the negatives outweigh hugely the benefits, I mean, I'm a skier, so I don't want winters to get much warmer than they are, but at the same time, a lot of people I can appreciate would quite like it if it hit 20 degrees regularly throughout the winter. Yeah.
They'll never do no good.
Yeah.
They're not going to do no good until they start targeting the world's leaders.
Yeah, but that's been ongoing.
A week after I come back, I went to the Brighton Technical College and I spoke to this Rob Joe. When you look at the world's weather on SBS, it says 15 in London, 35 in Bahrain, and by the time they get to America, they don't go no farther than Los Angeles. What about Sweden? What about Denmark? What about Norway? What about Greenland? You don't get no weather from there. And when I said that to Rob Joe, he said, I don't know what they're doing down there in SBS. He said, it's all a lot of crap.
I can't really comment on that, I'm afraid. Yeah, that's it.
You mentioned CO2 fertilisation effect.
Yeah.
There have done some studies, which you're probably aware of, where I guess the amount of plant growth is greater.
Yes.
But it's some of it, at least in some things, is shifting away from what we can eat.
Yes.
Into toxins.
Yes, exactly. And there's some really interesting work going on. I saw a talk by a local professor in biological sciences at Monash, and she did some great stuff about the nutritional value yeah, exactly. So while you get more stuff and you get higher yields, the nutritional value is plummeted. So there's all those nuances, absolutely. Absolutely. And that's why I said the negatives outweigh the positives.
Completely off topic. The world population growth is something that pops up time and time again.
I'm staying away from that one.
I understand what you're saying, but that's the problem, because if you bring the topic up, particularly with politicians, they go, because it's got a religious connotation. Because the moment you say world population growth, they say you've got to talk about abortion, you've got to talk about population control, all that sort of thing. And I remember Paul Ehrlich, when he wrote his population bomb back in the 60s, he had this phrase that said, whatever your cause is a lost cause unless you get population under control.
Well,
and they don't want to know it.
So just as an aside to that, it's interesting because I talked about some of the assumptions that go into these projections, your business as usual and whatnot. But in every single one of them, population actually stabilises at about 9 billion. And the reason that population stabilises, according to the economists anyway, is because of the increase in standard of living. And if you look at countries, developed countries have much, much lower birth rates. Much lower than developing nations.
When India and Pakistan got into their population war, which was about 1990, something like that. Yeah. The interesting thing there was that yes, as the living standard rose, the people whose living standards rose were the ones that didn't produce the children, and the people whose living standard wasn't changed, and they were in dire straits. They were breeding like crazy.
Yes, well, I'm contributing to the breeding like crazy. I can't talk too much.
I don't think humans are ever going to stop doing that. I'd be interested. I know it's off topic. I'd be interested to know, in looking at this, do you have a positive outlook on changing it and saving the day, or do you think we're doomed?
I have no idea.
What are we going to do?
I really wouldn't know.
Half the
I
world.
really wouldn't know. I think there's a question right over the back there, yeah.
Something I feel like my generation really deals with a lot is just the sense of apathy of, well, if the global warming isn't going to kill us, we're going to have a nuclear war eventually. And if that doesn't eventuate, well, China's currently abusing human rights, Sudan's having a political nightmare, Saudi Arabia only just gave women passports, what's the point? Why bother? It seems really something I think a lot of people really.
Yeah, and I think that's a very real feeling that a lot of people have. Apart from I talk about the global disconnect with this stuff is, this whole idea of dangerous climate change and 2 degree warming and inevitability. And I'm sorry to say, I'm fairly confident we're already there. That's inevitable now. But it's.
So what are you saying?
Well,
we can do to
no, but that 2 degrees I think is arbitrary. This whole idea of dangerous climate change and 2 degrees. I mean, any climate change is going to change things in ways that, but so in that sense, I get where that feeling comes from. But I think, I do have some, again, positive messaging, because I feel like if any change is going to happen, it's going to happen at the grassroots level at this point. And so I think that organisation, look at the influence Greta Thunberg has had. Huge. And this whole schools march for science, schools for climate stuff, that movement globally has been massive, absolutely massive. Time will tell how much of an influence it has, but it's got a lot of people empowered, it's got a lot of people doing stuff, and that's just happened in the past year or less. Yeah.
With your projection and modelling scenarios,
Mm.
how you showed us the two that were similar, one was actual, one was similar.
Mm.
When you're doing your modelling, are you using AI? Can you actually put feedback in of actually real data to come up with a better algorithm to actually get it to match what we actually have, and then maybe use that algorithm to predict the future?
Yeah, so as I said, these climate models are based on physics, and they don't draw in observations. It's not an extrapolation is what I'm trying to say, but they do draw in observations for their parameters. So what I mean by that is, let's just say we have, we need to work out how much incoming radiation there is on the Earth's surface from the sun, right? So how much sunlight is reaching the Earth's surface? Now, the way that these climate models work at the moment is, because of the intense computer power that they need, the Earth is basically broken up into these little cubes, right? Cubes in the vertical, cubes in the horizontal. And each cube, at least in the horizontal, is about 150 to 200 kilometres wide, right? Now, we can't measure all of the exact nature of the clouds in that box. We can only what we call parameterize it. We can only estimate it, average it, basically, right? And so the way that we do that and come up with those parameters is using observations in the real world. And we're constantly refining those. And because of that, these are constantly getting better. And a big part of it is actually just computing power limitations. We use the biggest supercomputers in the world for these things, and we're finding that as we can improve the resolution, so go from boxes that are 100 by 100 kilometres to 50 by 50 kilometres to 25 by 25 kilometres, some of those are being run on the big ones in the US at the moment. And we're getting much better results because we can all of a sudden see thunderstorms where we couldn't before. We can see, and all of that makes a difference, for example.
But you're not using AI?
Not for this stuff, no, because this is based on physics. So, I mean, the AI is usually actually my understanding anyway, the AI stuff is often a statistical method, what we call a Bayesian approach. And that's useful for some stuff, but not for running climate models.
I thought AI was more, they run the algorithm, and then you got to input when it's correct, and then it makes adjustments to come up with that figure. And then constantly narrows the window to get a more accurate reading until it's nearly got the perfect line of
Sure, but those are usually based on statistical relationships. And so to come up with those parameters I spoke of, yes, absolutely, people use things like AI. But to run the actual climate models, they're not based on statistical relationships. They're based on physical representations of buoyancy and physical representations of cloud microphysics and stuff like that. So they're actually kind of separate problems. They're not unrelated, but we do have what we call simple climate models, which do use things like AI, but they're statistically based on observations, and this is not that. It's a bit complicated to explain, but it's, back there.
Who's funding the grant for the media campaign?
The Lord Mayor's Charitable Foundation, the Melbourne Lord Mayor's Charitable Foundation.
Can I actually ask one last question, and that is...
and we give all our time for free for that, by the way, so I'm not actually paid to do that at all. That's just to cover like a project manager, basically. Yeah.
Is there a risk of fatigue in the media on climate? Now, I actually asked this because we're just sort of coming out of National Science Week, and there were 3,000 events across Australia. Only 6 were to do with climate. And here in Victoria, tonight was the only one had anything to do with climate.
Yeah, no, there is a lot of climate fatigue. A lot.
And it's amazing how many times the word Apollo.
Yeah. Oh, it was a good year. It was a special year for that. Yeah, no, it was a special year for that. We did. So I also co-host a radio program on Triple R on a Sunday morning. Einstein a Go-Go. I don't know if anybody's heard it. Yeah, I'm Dr. Ailie. Hi. So I'm on about once a month on that. But we did a lot of stuff last month on Apollo because our leader, fearless leader, Shane Huntington, who's Dr. Shane, he's a physicist and an astro guy. Well, optics, but anyway. he was very keen to do it. It's exciting.
Oh well,
Yeah.
please can I ask for your appreciation?
One of the things that we do with our guest speaker is that you get to draw the raffle prize.
I have the power.
And that's because if we draw it, they always say it's cheating.
Alright, here we go. This one?
Now we've got 4 tonight.
4 tonight.
So I've got a standard bottle of one giant leap, which is Shiraz. Simon's got a travel mate, which I guess works. We've got a box of chocolates for the lady with it, unless you happen to like chocolate. And a book on Elon Musk. I should say that Elon Musk's car has now done 1 full orbit of the sun.
Oh.
So he's managed to drive his car, and his astronaut's still sitting in the car, driving around the sun. I've probably got a lot of sunburn.
Alright, I've got one.
Yeah. We always do these things really tight, and it takes forever.
Oh, you got it.
I'm going to grab another one.
Yes.
Peter can work on this. Right. Number 43.
I grab the elongated book.
Oh, you don't count. Committee members are not allowed on the...
Next one is 51. 51.
Number 51. 51.
Yeah, that'd be pretty.
Oh, okay.
Another bloody committee.
That's alright.
That's all right. Yeah, you can have the lovable car.
Mark.
Let him choose
I'm
himself.
off the bloody
Let him
box.
choose himself.
Number 52.
Conspiracy.
Number 52.
Oh, yeah, that's me as well. We draw it.
Here we go, 35.
35. Some road there.
35. You have a choice. I'm lucky you are.
48.
It's a silent We only have a check with Ian's doing it, because he always gets drunk. Yeah.
Okay, well, given we've...
No, thank you.
And we'll call on Ian Sullivan to thanks for the speech.
Everybody knows what I'm going to do. I'm going to present a bottle of wine to a good speaker. She's used to lecturing well, and I've heard some terrible lectures lately, but tonight's was pretty good. And you're at all interested in the subject, you couldn't go away dissatisfied tonight.
Thank you very much.
There we
Yeah, a couple of months and I'll save that one.
Well, given the time of the evening, I think we'll break for a cup of coffee and a cup of tea now for 10 minutes, and those who wish to stay on to hear some more from us can do so, but I think it's probably time for a little bit of a break.
Yep.
All right. Thank you. Come back in here about 10. Okay, for those of you who are still here,
I'm going to buy a Huawei phone.
I'll just spend about 5 or 10 minutes maybe just going through some of the things that we've done over the past month. Many of the people will have already gone, particularly if they've got a fair distance to go. And
How's we going?
Right, so since the July meeting, we had a public viewing night on the 19th of July, which was there especially for Apollo, and we had 76 turn up for that. Then we had the 50th anniversary dinner, which was after the previous viewing night, after the previous meeting, and that was a good turnout in here as well on the evening. Then we had a long distance viewing night out at Epping for St Mary MacKillop Primary School, where they specifically wanted a talk rather than telescopes, so they were more interested in an astronomical talk, and as it turned out it was cloudy, so if it had been clear they would have had telescopes as a bit of icing. On the 2nd of August we had the usual public viewing night, and we had 90 turn up for that. Then on the 7th of August we had the first Mornington Cubs here, and there were a few dozen of those in this room, and that was where I first lost my voice the day afterwards, because it was a terrible night in terms of rain outside, so the talk had to go for at least an hour and a half, and I was just getting over a cold, and consequently on Thursday I lost my voice after straining it. Then on Friday evening of 9th of August, the 17th Astroc was here at the Briars and next door at the camp, together with the astrophotography workshop for the first time, and both of those were really successful events as well. The video of the keynote speaker by Brad Tucker is actually up on YouTube at the moment, so if you weren't able to see it at Astroc, it's on the Society's YouTube channel. And he's kindly allowed us to put it up there. On the 11th of August, after Vastrock and the workshop finished, we quickly went down and set up our large marquee down at Coolah. Marquee is about half the size of this room that we're in at the moment, so a decent sized one. And we had 5 or 6 of us down there for the day. Bit drizzly to start with, but nevertheless, the counters at Coolah counted 600 cars go in, which means there's at least 600 people probably came by us, and probably double that. So apparently, like here at the Briars, where they've instituted a car counter, and I think even a people counter, they've done the same at the park at Coolah now, but they just haven't got the numbers in for the people counter. I'm not sure how a people counter actually works if you're walking through a gate, but I suppose technically it must be possible. Then on the 13th of August we had Peter Lowe, who's now left, talk at Mornington Library, and I think he ended up with about a dozen or so people turn up to that, including a couple of members as well. Excuse me. And the next day we had 2 events on that night. One was a talk only at Frankston Library that Trevor Hand kindly took hold of, and gave them a talk about meteorites. And simultaneously with that we went down to Mount Martha Primary School, which is only 5 minutes away from here, just in time for their 780 kids to have an all-of-school science day, and we were the last thing on the bill. Interestingly, with that school, we visited them many times over the years, in fact 10 times we've previously visited them. But we still encountered parents there who didn't know we even exist, and we're maybe 1 kilometre away from them. And one of them actually won the raffle at the concert, and when I delivered the prize round to his place earlier in the week, I actually asked him about it, and they just hadn't heard about us via any medium, so hard to believe.
Do you know if the schools utilise their newsletter for like MPAS events and stuff?
I don't think they do it regularly.
Okay.
In this particular case, I think we got a mention because we turned up. And we also had Daniel Price, lecturer from Monash University, who was there with his telescope on the night as well, and he's shortly going to be a member as well down here, because he lives down on the peninsula, and he's trying out his new Dobsonian. So as he said, he now considers himself a real astronomer now that he's got out with the school with his telescope. On the Saturday evening, we had the long-awaited for concert with the Southern Peninsula Concert Band, which is held in this room, and we had about 26 members of their band orchestra at the front here. Usually it's about 30, but some people were missing on the night. And aside from the 30 sitting up the front here, and me doing a talk every now and again up here, we had 100 people on that side, and at least 100. I think a couple of others were squeezed in as well. And we somehow managed to survive that.
How about over these sorts of surfaces?
It went perfectly well. It required some modification in the sense that, notice in here though, that there's no bare metal walls anymore, they're all lined. And the big worry was actually the concrete floor. So we had rubber matting down in this area here for the band to sit on. And that and the sound dampening of having 100 people in the room worked perfectly. And in fact, the music director who was conducting them was really pleased with the sound inside this room compared to what they thought it might be. We even issued earplugs to everyone on the night just in case it was going to be too loud, but as it turned out, it wasn't necessary. We laugh at that, but the next morning, Ros and I were up to Melbourne to go to a Hugh Jackman concert at Rod Laver Arena, and he actually on the stage said to a few people that he could see were putting their fingers in their ear because they were too close to the speakers, offered them earplugs and even headphones for anyone in the stadium. Now there would have been a bit of a problem if 70,000 people had put their hand up, but yeah, it's not unheard of to go to a concert and be offered earplugs. So it attenuates the sound, but went really well. Whether or not it will occur on an annual basis, I suspect it's probably more likely to be biannual if the band was agreeable, because there's a lot of work from their side of things as well. They've been rehearsing for the best part of a year on the pieces, and some of the people in the audience were like spouses of members in the band, and they said that was the first time that they'd ever heard it all come together, because they've been hearing their spouse practicing their bit at home for months and months, but this was the first time it all came together at one, and they were really impressed by that. So we drew the raffle for the first of the moon rocks, one of the lunar meteorites, excuse me, and that was given to a visitor down from Sydney. So we had one visitor come down from Sydney for the concert and also one from Canberra as well. Wasn't aware of any others from any other state, but they came from far and wide just for that weekend. And we've also been doing the national school competition over Science Week for a second moon rock. And that was to estimate how many craters there are on the moon. And I won't go through the details of those now. But it was won by a boy in Geelong. Interestingly, of all the states in Australia, Victoria had about half of the entries that were submitted, and the next biggest state was Western Australia in terms of submissions, and the smallest was Northern Territory and ACT. But I'll go into the details of how many craters are on the moon in the next meeting. And I'll go through some of that. So here's some of the concert feedback that has been received by people in writing. And as you see there, people seem to have had a really good time on the night. And I see Nerida's not in here; she's outside. But I had a couple of, in fact, 3 ladies come up to me at the end of the concert and said that they wanted to be rescued by the man in the blue and yellow uniform who was Nerida's husband, dressed as Virgil from the Thunderbirds, so he was in his Thunderbird outfit. So the way that the concert held together was using science fiction. So in other words, that was the bridge between us giving a few short talks on science-related topics to do with astronomy and the tunes that the band were actually playing, because there are very few science tunes as such, as opposed to plenty of well-known ones from the realm of science fiction.
Did they sing Green Hills of Earth?
No, they didn't. They had many things that they could choose from.
Do you remember that one?
No, I don't. No.
That's very special to me.
And there were literally, when we brainstormed the possible tunes, there were hundreds and hundreds that were related to space and astronomy in some way, that most people would go, oh yeah, I've heard of that one, or I do know that one. So
the Green Hills of Earth is actually on YouTube. There are about 4 versions of it.
So the challenge for this one was to whittle it down to something that could be put together in a story timeline. And also for them to get the scores, because you have to have the rights to actually play the music, and some of them they had to actually go off and buy the sheets of music and the right to actually play it as well as part of the exercise. But I'd have to say probably the most fun one was where I was standing up here looking at the audience, sort of nodding their heads side to side, was the tune of the Thunderbirds. Right, so I think that probably says something about the age of the people in the audience. Now, before we're here for the next meeting of MPAS, we've got a school that we visited a few times, this time down at Merrick's, coming up in a couple of weeks' time. That one will be by invitation, because it's only a small number and also quite a distance away, so I don't think we're going to need a general call on telescopes for that. We have the regular public night in September. Then Baden Powell Scouts were going out to their scout hall again in Frankston South. And we're expecting around about 50 there. Then the combined Scouts and Guides night, a couple of days later, here on the Friday, we've got a group coming over from Ringwood East, quite a large group, about 60 odd Scouts. And also some Cubs from up Aspendale Way have booked themselves in for that one as well, for their astronomy badge. And I believe we don't have any members' barbecue nights, I think as Greg said, a little bit earlier before our next meeting. And with that, I will say, is there any other business to bring up? And obviously the audio on this thing is not working, but it doesn't matter. You can sort of see what he's doing.
Yes, you can see exactly what he's doing. Sure.
He actually says the final block on the back there weighs 100 kilos. Right, so that one that he's lifting up, I don't know whether it is 100 kilos. He lifted that a bit too easily for me for 100 kilos. Maybe it was 100 pounds.
That's scary. Here we go.
Did this on Mythbusters the other day.
Did they? Oh, yeah.
There we are. One tiny one can have an impact. And sort of the idea there is that one sort of small idea put forward by someone can end up turning into a very large delivered idea, delivered project at the end of the day. Okay, well with that, I think we'll close the meeting at 10:15, and we'll see you here next month.